Hi friends, this is Rashekar, a GATE faculty for electrical machines. Today in this video, we are going to discuss about losses in our transformer. What are the different types of losses and how we can calculate them. Generally, in our transformer, two types of losses are there. You know very well. Two types of losses are there, that is low frequency losses or power frequency losses. Next one, high frequency losses and low frequency losses. This low frequency losses, again two types. Those are iron losses and copper losses. This iron losses is also called core losses. These core losses are also called no load losses, because even under no load condition some losses will there. Those are called no load losses, iron losses or core losses, and these are copper losses. Of course, this high frequency losses also again two types. One is the stray load losses, other one is the dielectric losses. Stray load losses and dielectric losses. This is generally the classification of losses. This iron losses are core losses, again two types. You know that. One is the hysteresis losses. Other one is the eddy current losses. And this stray load losses also again two types. One is the copper stray load losses and other one is the iron stray load losses. This is completely what are our losses. This much of losses are there in our transformer. First see this. In generally, dielectric losses takes place at dielectric media, nothing but insulation. Takes place in insulation. In generally, takes place in insulation. Insulation between windings, insulation between laminating plates, etc. At those places, some losses will take place. Those are called dielectric losses. The percentage of dielectric losses out of total losses, the percentage of dielectric losses is just 0.25% only, not even 1%. Just 0.25% only. The dielectric losses formula P is equals to V square 2 pi F tan delta or delta. Tan delta is the dissipation factor. This is the omega, and C also is there. Capacitance, the dielectric media capacitance, and V square 2 pi F. Nothing but the dielectric losses are mainly depends on voltage square. This is not depends on current. This is depends on voltage square. This is about dielectric losses, very minute losses. Next, stray load losses. These stray load losses are mainly two types: copper stray load losses and iron stray load losses. Copper stray load losses takes place in the copper, nothing but in the winding, in our winding. And iron stray load losses takes place in the iron, nothing but core. Steel, nothing but iron, right? This copper stray losses are due to stray currents or circulating currents in the winding. In the conductor, some circulating currents are there. Due to that circulating currents, some losses will take place, that is called copper stray load losses. These are minimized by this circulating currents by using the what is the insulation in between them. Right? These are the copper stray load losses which occurs in the winding. And iron stray load losses occurs in the core due to leakage flux. This is due to leakage flux. When this leakage flux interacts with the core or transformer tank or any steel rods, in that case some losses will take place, that is called iron stray load losses. This is mainly due to leakage flux. Sir, what is the percentage of this stray load losses? What is the percentage? This stray load losses percentage is total comparatively compared in between these all losses. The stray losses percentage is just 0.5%. Combinedly, the high frequency losses are less than 1%. That's why these are negligibly small. That's why in some textbooks they won't mention about high frequency losses, because these are minute losses, very small losses. That's why no need to talk about this one. Now the major losses are low frequency losses, normal losses. This is very important for us. Problems also very important. They will ask you question in our GATE exam based on these losses. Okay, so now here a simple classification. These copper losses and stray load losses and dielectric losses, these all are the variable losses. These all are the variable losses. They changes with respect to load. But this iron losses or core losses or no load losses are constant losses. These are the constant losses because these are independent of load. Even load is there or load is absent, these losses will exist. That's why these are also called constant losses. Why? Because these are called constant losses because these are independent of load. These are not depends on load. Not depends on load. These are not depends on load, but these are depends on load. That's why these are called constant losses. So if you remove this part, we have two types of losses. One is the constant losses, other one is the variable losses. One is the constant losses, other one is the variable losses. Yes. Let's see about constant and variable losses in our transformer. Let's see what are the constant and variable losses in our transformer. Right, let's see here. So generally the losses in the transformer two types. One is the constant losses and other one is the variable losses. This constant losses is also called core losses. Core losses or copper losses are also called variable losses. Generally, the full load copper losses is equals to formula I square R. If you want to offload copper losses is equals to, when load decreases, which of the following is varies? Resistance or current? Current varies ultimately. So offload copper losses is equals to half of the current square into R, I square R losses. Half of the current square can be written as half square I square R. Half square I square R nothing but half square I square R. What is I square R? I square R nothing but full load copper losses. So half load copper losses, half load copper losses is equals to half square into full load copper losses. If they ask you question, 2 by 5th load copper losses is equals to 2 by 5th load copper losses is equals to 2 by 5 whole square multiplied with the full load copper losses. If they ask you question, xth load copper losses is equals to x square multiplied with the full load copper losses. X may be 1 by 2, x may be 1 by 3, x may be 1 by 5, x may be 2 by 5, whatever the value. The copper losses, very very important formula. Xth load copper losses is equals to x square into full load copper losses. This is about the copper losses. Okay. Next, constant losses or core losses. This constant losses or core losses are two types. We know already. One is the hysteresis losses, other one is the eddy current losses. What is the formula for eddy current losses? Eddy current losses formula K B maximum square F square T square. This is the formula actually. And what is the formula for hysteresis losses? Some neta B max whole power x. That x value is 1.6. B max whole power 1.6. F into V. Here V is the volume of the core. This is a hysteresis and eddy current losses formula. Hysteresis and eddy current losses formula. In this eddy current losses, for example, my assumption, if V by F ratio constant, tell me sir, what happened if V by F constant? We discussed earlier in EMF equation. V by F constant nothing but B maximum also constant. K is already constant, now B maximum also constant. Then tell me, eddy current losses are directly proportional to F square. Of course, the thickness is also constant, we won't change once transformer manufactured. So, all are constant, the eddy current losses are directly proportional to F square when the V by F ratio constant. Very very important. When V by F ratio constant, the eddy current losses only depends on frequency. For example, if V by F ratio constant, neta is already constant. If V by F constant, I said you B maximum constant, volume constant. So when V by F constant, hysteresis losses also directly proportional to frequency. Hysteresis losses also directly proportional to frequency. Are you okay? Understanding or not? Now see here. For example, if V by F ratio not constant, if V by F not constant, B maximum also not constant. If B maximum not constant, the hysteresis losses directly proportional to neta constant, volume constant. But B maximum not constant, B maximum frequency. But B maximum can be written as V power 1.6 and F power 1.6 because B maximum is nothing but V by F. Now if nothing is there, nothing but 1 is there, 1 comes. So tell me, what is hysteresis losses formula? Hysteresis losses directly proportional to V power 1.6, 1 minus, so F power 0.6. Very, very, very important. This is very, very, very important actually. This is also important. This is when V by F ratio not constant. For example, in eddy current losses also, if V by F ratio not constant, when V by F not constant, eddy current losses directly proportional to B maximum square and F square, because K and thickness already constant. Now tell me, eddy current losses are directly proportional to V square upon F square and F square. Now tell me, eddy current losses directly proportional to V square, because F square cancelled out. F square cancelled out. This is the losses in our transformer, which is very, very, very important. The copper losses, hysteresis losses and eddy current losses, and its formulae. Are you okay? This is very important, right? Thank you.